factorization and Cholesky factorization, respectively. So that means you need to solve this linear system by the two methods, okay? LU factorization and Cholesky factorization, respectively. Okay, now this system 410152028, 3 unknowns x1, x2, and x3, a right term 5, 8, 10. Okay, now let's find the LU factorization firstly. Okay, so you should know how to obtain, perform LU factorization, right? Because here we just use LU factorization, so we don't use partial pivoting. It's okay. You should understand, okay, what is the difference between regular LU factorization and partial pivoting LU factorization. It's okay. So because we don't use partial pivoting, so we don't interchange rows. Okay. So first step, we need to use 4 as pivot. Okay, 4 is the pivot. So we need to find the multipliers. So here, this small matrix is L1, right? Okay, L1 is the lower triangular matrix, right? Ones on the diagonal, 1, 1, 1. So you only need to find 2 multipliers. Okay, first one, this number should be 1 minus 1 divided by pivot 4. So minus 1 over 4. It's okay? And this number is 0. So actually, I don't show. Of course, you can write the second multiplier by 0. Okay? Then you obtain L1. So I write L1 here. I write L1 here. It's okay? And then you will obtain U1, right? Okay, A1. Okay, first row is not changed. 4, 1, 0. And this number should be 0. Also, this number should be 0 because you use, so you use L1. So I write here, L1 multiply A. So it is 1 minus 1 over 4. 0, 1, 1, multiply 4, 1, 0, okay, 5, 1, 5, 2, 0, 2, 8, right? So you need to compute the matrix. So actually you don't need to compute the first row. You just write it, repeat it, okay? 4, 1, 0, 4, 1, 0. Okay, also these two numbers should be zeros, right? So you use the second row, multiply first column, you will obtain 0. Okay, and then you use the second row, multiply second column, so it is, okay, should be 5, right here, 5 minus 1 over 4, right? So it should be 5 multiply 4, 20 minus 1, 19 over 4. So here should be 19 over 4. It's okay? And the second row multiply last column. So minus 1 over 4 multiply 0 plus 1 multiply 2. So it is 2, right? Okay, last row multiply each column because last row is 0, 0, 1. So that means you don't change last row. So 0, 2, and 8. Then you obtain this matrix by L1 multiply A. It's okay? Okay, continue. We need to use this number, diagonal element, 19 over 4 as pivot. Okay, so you just need to write this matrix by L2. So L2, 1, 1, 1, only one multiplier. This multiplier equal to minus 2, this number, right? Minus 2 divided by 19 over 4. Okay, so reverse, it is 8 over 19. Okay, so this is L2. Okay, and you use L2 multiply L1 multiply A, then that means you use 1, 1, 1, and minus 8 over 19 multiply 4 1 0 0 19 over 4 2 0 2 8. Okay, let's compute the matrix. You don't change the first row, and the second row you don't change, right? So you only need to compute the last row. So last row multiply first column, it should be 0, right? And the last row multiply second column, it also should be 0. Actually, you only need to compute the last element, right? So you use 0 multiply 0 plus minus 8 over 19 multiply 2. So I write here minus 8 over 19 multiply 2, right? Plus 1 multiply 8. 1 multiply 8. Okay? So you will obtain the denominator should be 19, right? So here is 8 multiply 2. So it is 16, right? Minus 16 plus 8 multiply 19. So you will obtain 136. Okay, so you can use the calculator. Okay, so you obtain U. So this matrix, the last matrix is U. Okay. Now you need to write A into LU factorization. So we obtain matrix U like this, and you need to write matrix L, right? How to obtain matrix L? Now we obtain L1, L2 here. So you should know the matrix L is L1 inverse multiply L2 inverse. Remember, because we obtain here U, this matrix U equal to L2 multiply L1 multiply A. So you move reverse L2 and L1 to the side of U, you will obtain L, right? So multiply L2 inverse, L1 inverse, so you will obtain L. Okay, and you should remember, actually you don't need a computer, because we know the property of the matrix, because L1 and L2 are lower triangular matrix with ones on its diagonal. So you only need to change the sign under the diagonal elements and put them together. So you will obtain 1, 1, 1, and change the sign minus 1 over 4 to 1 over 4, right? Directly 0. Here is 0, right? Here is 0. And for this number, change the sign, so directly 8. Okay, so you see you obtain L matrix. Here, of course, you can check A to make sure you obtain the correct answer. Okay, so continue. We need to solve the linear system by LU factorization. So you should know the original system is AX equal to B. Now we factor A by L multiply U. So LUX equal to B. Then denote UX by Y. Then we obtain LY equal to B. That means we obtain two triangular system, right? So firstly, we solve the first system by L multiply Y, Y1, Y2, Y3 equal to B, B 5, 8, 10. It's okay? This is L you obtain here. Right? Okay, now we can use forward substitution to obtain Y1, Y2, and Y3. So firstly, we know Y1 equal to 5 directly, right? Y1 equal to 5. And the second, okay, we know second row multiply Y1, Y2, Y3 equal to 8. So here, I write here to show you the detail. Okay, so that is 1 over 4 multiply Y1 plus Y2 multiply Y2 plus 0 multiply y3 equal to 8, right? So equal to 8. Then we can know y2 should be 8 minus 1 over 4 multiplied y1. Because y1 is 5, okay, so you will obtain the answer is 27 over 4. Clear? Okay, last we obtain y3 by this last row multiply equation. Okay, so it should be 0 multiplied y1 plus 8 over 19 multiply y2 plus y3 equal to 10, right? Okay, so y3 should be 10 minus 8 over 19 multiply y2. And y2 is 27 over 4. Okay, so you will obtain, by calculator or by hand, you can obtain 166 over 19. It's okay? Please check, okay? You already practiced, so you just need to check. Okay, now we obtain y1, y2, y3, then put to the right side of y and solve ux equal to y. So this matrix here. Okay, now we need to use backward substitution, right? Okay, now you see the last equation just be 36 over 19 multiply x3 equal to the same number. Okay, so we obtain x3 equal to 1, right? Okay, second equation means right here 0 multiply x1 plus 19 over 4 multiply x2 plus 2 multiply x3 equal to 27 over 4, right? Okay, so x2 should be 27 over 4 minus 2 multiply x3, then divided by 19 over 4. That means multiply 4 over 19. Okay, because x3 is 1, so just the answer should be 1. Okay, and now we obtain x2 and x3 are 1, then, let's check the first equation. I write here. So it is 4 multiply x1 plus x2 multiply 0 plus 0 multiply x3 equal to 5. Okay, so x1 should be 5 minus x2, bracket divided by 4. So, of course, it is just 1, right? Okay, now you see, at last we obtain x1, x2, x3 by 1, 1, 1. It's okay? Of course, you can check the answer, right? 4 plus 1 equal to 5. Okay, the summation of 1, 5, 2 is 8. The summation of 2 and 8 is 10, right? So you obtain the correct answer by LU factorization. Clear? Okay, next we need to use Cholesky factorization. So you should understand what's the difference. This is LU factorization, and what is Cholesky factorization means, because this matrix, now you see, it is symmetric, right? Symmetric and positive definite matrix. So we can use Cholesky factorization. That means we can factor A by L multiply L transpose. Okay, so the question is how to obtain L, right? Okay, so actually you should understand, because we should obtain unique LU factorization, and Cholesky factorization is a special case for LU factorization, right? Okay, so let's try. Okay, Cholesky factorization. So that means we need to find A equal to L multiply L transpose. So L is a lower triangular matrix. So L11, L21, L31, L22, L32, L33 multiply is a transpose. So 1, 1, 2, 1, 3, 1, 2, 2, 3, 2, 3, 3. Okay, equal to A. Now, we don't use Gaussian elimination. We obtain the numbers directly by the product rule, right? It's okay? So here, let's check. We use first row multiply first column to obtain 4, right? So it is just L11 square, right? So we know L11 square equal to 4. So L11 equal to square root of 4. That's just by 2, right? And then we check, okay, L21, second row multiply first column, right? So L21, that means I write here, L21 multiply L11 plus L22 multiply 0, right? This number is 0. Okay, so it equal to 1, equal to this number 1. Clear? Okay, then we obtain L21 should be 1 divided by L11. Okay, so it is just 1 over 2. Clear? We obtain L21. Now, if we want to find L22, then we need to use this number. Okay, so if we use second row multiply second column, then that means L21 square, right, plus L22 square, right? Second row, now we use second row multiply second column, okay? And equal to the diagonal element is 5, Of course, in my lecture, I told you you need to compute L31 firstly. Of course, you can compute L31, but now because I write this answer in the same row, so I explain here like this. It's okay for you? Okay, so by this equation, because we already know L21 here, so we can obtain L22 by square root of 5 minus L21 square. Okay, so you will obtain this number. Okay? Okay, continue. Let's compute L31. L31, then we use third row multiply first column. Then it is L31 multiply L11 equal to 0, right? Because this number is 0. Okay, this number is 0. That means L31 is 0. Clear? Okay, let's come to L32. L32, then we use last row to multiply second column. So that means L31 multiply L21 plus L32 multiply L22. Now equal to, because third row multiply second column, so it is third row second column, so it is 2, right? It is 2. And when we know L31 is 0. So actually, we only need to solve L32 by 2 minus L21 multiply L31. Actually, this is 0 divided by L22. So it is just 2 divided by L22. So you will obtain 4 divided by square root of 19, right? Okay? And the last number, L33. So you use third row multiply third column. So you will obtain L31 square plus L32 square plus L33 square equal to 8, right? This number. It's okay? And so we can obtain L33 by 8 minus L31 square minus L32 square and compute its square root, right? It's okay? And then you can check. You will obtain this number. Okay, square root of 136 over 19. Okay, then you can obtain L like this. L11, 21, 22, 31, 32, 33. Clear? Okay, this is Cholesky factorization by L, right? And you should understand the difference between LU factorization and Cholesky factorization. Here, the L is a lower triangular matrix with ones on its diagonal, right? With 3, because here 3 by 3 matrix, so 3 ones here. Now you see. Okay, but for Cholesky factorization, L is not, it is a lower triangular matrix, but its diagonal elements are not 1, right? It's okay, maybe not 1. So here, it is by square root, okay? Now you see square root here, square root here. It's okay? So this is the difference. Okay. Actually here, you can also solve the linear system by Cholesky factorization, okay? Because now we already know A equal to L multiply L transpose. So AX equal to B is equivalent to L multiply L transpose X equal to B. So it's equivalent to L transpose X equal to Y, then Ly equal to B. It's okay? And also, you can solve the two linear system like LU factorization to solve this one and this one. Okay? L and U. Okay, I omitted the details because you will obtain the same answer as the LU factorization. You will obtain at last x1, x2, and x3 should be 1, 1, 1. Okay, so I omitted the details. Okay, let's come to the second question. Let matrix A be 1, 0, 2, 3. We need to find 1 norm, 2 norm, infinity norm, and the spectral radius, rho A, and also we need to find the condition number. Okay? Here you should know the subscript is infinity, so that means we use the infinity norm. Okay? So here you need to understand and also you need to remember the definition of the 1 norm, 2 norm, and infinity norm, right? It's okay? Okay, actually, the simple 1 norm and infinity norm are simple, right? But for 2 norm, you need to compute the eigenvalue, spectral radius, actually, the eigenvalue of ATA. It's okay? So here I show you 2 norm firstly. So ATA, A transpose multiply A is 1, 2, 0, 3 multiply 1, 0, 2, 3. It's okay? So the first row multiply first column, you will obtain 5. And also you can check, okay, I omitted the detail. So 5, 6, 6, 9 is a product. And you need to compute the eigenvalue, right? So lambda I minus ATA. So lambda minus 5, minus 6, minus 6, lambda minus 9, right? Okay, you need to compute its determinant, right? Its determinant is lambda minus 5 multiply lambda minus 9 minus 6 multiply minus 6. So it is 36, right? Okay, then we can obtain lambda square minus 14 lambda plus 5 multiply 9, 45, right? And minus 36. So you will obtain this polynomial. It's okay? And then you can compute the two eigenvalues, okay, by the formula, we just use minus b plus or minus b squared minus 4ac divided by 2a, right? It's okay? So here, minus, because b is minus 14, so it is minus minus, it is 14, right? 14 plus or minus square root of b squared 14 square minus 4ac, 4 multiply 1 multiply 9, this is 36 over 2, right? Over 2. Then you can obtain it is 14 plus and minus this number, you will obtain 4 multiply square root of 10 and divided by 2. Okay, so 7, right? Then you will obtain lambda 1 and lambda 2 by 7 plus 2 multiply square root of 10 or 7 minus 2 multiply square root of 10. So you should choose the maximum one, right? And don't forget square root. So because you should remember, I write here, the 2 norm should be square root of lambda maximum ATA. It's okay? You should remember this formula. So lambda means the eigenvalue, maximum eigenvalue, and the square root, right? So the maximum one should be 7 plus 2 multiply square root of 10. So don't forget another square root. It's okay? So if you obtain this number, that's okay. That's okay. Of course, it's not necessary to use calculator, right? You obtain this number. I know what you mean. Okay? So I know you understand the formula. That's okay. So this is the 2 norm, right? And then more simple, for 1 norm means the column norm. So for first column, the summation of the absolute values is 3. The second column is also 3. 3. So the maximum number is also 3. It's okay? And for the infinity norm means the row norm. First row is 1. Second row, the summation of the absolute values is 5. So 5 is the maximum number, right? Okay, so infinity norm is 5. Clear? Clear. And also we need to find the spectral radiance. For spectral radiance, you need to compute the eigenvalues of A. Now you see, A is special structure. It is lower triangular matrix. For triangular matrix, the diagonal elements are its eigenvalues. So we can obtain the 2 eigenvalues directly, 1 and 3. So the maximum is just 3. It's okay? Because A is just a lower triangular matrix. So the diagonal elements just its eigenvalues. Clear? So the maximum one is 3. Okay, so spectral radiance. Okay, last one, the condition number of matrix A. So you should remember, now condition number, we use infinity norm. So it means you need to compute the A infinity norm multiply the infinity norm of A inverse. It's okay? So you need firstly to compute A inverse. Okay, because it is a lower triangular matrix, so it is easy to compute its inverse. It's okay? So here I show you directly A inverse by 1, 0, minus 2 over 3, and 1 over 3. It's okay? Actually, you should remember how to obtain the inverse. At least you can compute directly by solve the linear system. Okay? So here is the A inverse. Now we can compute its infinity norm. So first row is 1, right? And the second row you should use absolute value of 2 over 3 plus absolute value of 1 over 3. So it is 1. Okay, so 1 and 1, so the maximum number is also 1, so we know the infinity norm of A inverse is just 1. So 5 multiplied 1 is 5. Then we obtain the condition number. Clear? So this is a second question. Okay, the third one, we are given this vector, right? This vector, we also need to find 1 norm, 2 norm, and infinity norm. Okay, so you should remember for vector, 1 norm is the maximum, one norm is the summation of the here I from 1 to n. If n-dimensional vector, absolute value xi, and you should compute its summation of the absolute value of xi. It's okay? This is total score, right? So we need to compute 3 plus 4 plus 12, right? So it is 19. It is 19. So x1 norm. Clear? The total score. And for 2 norm, so it should be summation of I from 1 to n xi square, right? Then square root. Okay, so it should be right here directly the square root of 3 square, so it is 9, right? Plus 4 square, 19, and plus 12 square, right? Okay, you can obtain the answer should be, okay, at last the square root is 13, okay? Clear? You can use your calculator to check. And also last one, infinity norm, okay? For infinity norm, that is the maximum number of xi. Okay, I from 1 to n. Okay, so 3, 4, 12, the maximum number, of course, it is 12. Okay, so we obtain the infinity norm. Clear? So this is a question, last question of chapter 2.